The other thing I want to show you today, there's really only two things. The other thing I want to show you is something that I think is very valuable, because this last thing that I showed you, the most recent thing that I ran here, this little interface, I did not code that interface. I prototyped it entirely in ChatGPT, and it was super easy, and it saved me a ton of time. Now, here's the thing. In order to prompt ChatGPT correctly and know what you're getting out of it, it is really useful to know how TK interface works. So this isn't something where like, oh, why did I learn how to use TK interface if I'm not going to be coding all of these things by hand? Because if you don't know how to use TK interface and you just tell ChatGPT to generate something for you, you might not know how to articulate that. You might not know how to what to tell it to do. And I gave it a very specific set of instructions, and it just gave me that interface back. And now all I have to do is attach my code to it to make it functional, which saves me a lot of time. It also gives you the ability to very easily and very quickly think about what you want your interface to look like. Okay, so prototyping with ChatGPT, let me just show you the basic process. And I'm actually going to get into ChatGPT. Now, there's a free version, but it's not the one I'm using. I'm using the paid version of ChatGPT, which gives me access to GPT-4, which is a more powerful model. You can do this in GPT 3.5, which is the free version that's available to you. GPT-4 is just a little bit better in terms of, so your results may vary a little bit, but you can still do this in principle. So what do I want? Let's do a different program. So one of the other things that we did earlier in the class was the rock, paper, scissors. Okay, so I'm going to start my prompt with ChatGPT saying, I want to use Python to make a Python and, let's say, and TKInter to make a rock, paper, scissors game. Please create the interface for me. It should have buttons for the user to choose rock, paper, or scissors. These should be in a frame on the left side of the window. I'm going to go back after the interface, and I'm going to actually add the window should be 800 by 400. Okay, so I'm giving it instructions, and you'll notice I'm using words like frame, buttons, those sort of things. On the right should be another frame showing the computer choice. In the middle, a third frame that shows the user and the computer's score in large letter numbers with appropriate labels for each. Okay, so let's see what this does, and it might take a moment. And it's not just give me the code GPT, it's chat GPT. So it's going to describe what it's doing. But here comes, and you will see that not only is it doing this for me, it's actually doing some of the wiring up of my functions for me. So that is nice. And then it explains what it did afterwards. So it did what I said. Let's see how it looks. I'll save that. Just paste that after. Okay, now let's run it. See what happens. That's pretty good, right? It's a pretty good start. So the computer's choice, what I had in mind was a little bit more like one third, one third, one third. It's not bad though. So now, once I had that, I can say, can you modify so that the frames each use one third of the window? Okay, now I could prototype this by hand. But once I understand how this code works, I can do it much quicker this way. And there's no disadvantage to doing that. What I'm trying to model for you here is that you can take shortcuts once you know the stuff. And sort of the idea behind that is that if you know how to do the stuff, you're better at taking shortcuts. You know how to do the shortcuts better. And if I didn't know the proper terminology or how TK interface worked with frames and how it organized the screen, I wouldn't be able to do this so well and so accurately. And now we're getting a little bit better. It looks a little wonky, but here's the problem, and I can tell this right off because I know what I'm doing. It didn't use pack propagate set to false. So these frames are shrinking down to the size of the content. So I can go back and now I can tweak this very easily, but this gives me a great start. And you can even see here that, let me just go back up here. I want to explain part of this. There is a user choice function that it's defined. And all it does is say, it just prints out what the user chose to the Python console. But here is an interesting thing. Do you remember how I said when you attach a function to a command, you can't use parentheses? Here's a way around it, okay? And you probably won't remember this, but it's called a lambda function. And what it does is it says command equals lambda and then colon, and then you can list your function with arguments, with parentheses. And what lambda is just a basic generic wrapper function. All it does is turn around and call this. So lambda is a way of putting a function with arguments as a button command without having it called when the thing is or when the code is run. And you can see here, as I click those buttons, we're getting those results. So that could be fed into some of the functions that we already did for rock, paper, scissors. And all you would need to do is figure out how you update the user score, the computer score, and announce the computer's choice each time the user picks something. Now remember, this is event-driven programming. Event-driven programming says, I'm going to wait for the user to do something, which will trigger that. So before, we had the computer choose, and then we asked the user what they wanted to choose, and then it did the computation and did the score. In event-driven program, we don't want the computer to be doing stuff in the background. It's just wait for the user. So the user picks, which will trigger the computer's choice and the comparison, which will update the score, and then it goes back to waiting for the user to pick again. So those are the things. You also probably want to figure out how to announce when the game is over. So what do you do when the game ends? Somebody wins or loses. But I just saved myself maybe 20 or 30 minutes of coding by typing out a clever prompt, knowing what I'm doing, and actually implementing it that way.